Good morning, my dear students. In previous classes, we studied about sequential lobing, conical scan, and monopulse tracking radar, where these how the working of these radars will depend upon the comparison of the amplitude of the echo pulses returned from the different antenna positions. That's why they are called a amplitude comparison monopulse radars. But the next concept is phase comparison monopulse radar. In phase comparison monopulse radar, the angle of arrival in one coordinate is determined by comparing the phase difference between signals from the two separate antennas. We are going to use the two separate antennas. And the individual bore site axes of the antennas are parallel and causing the radiation to eliminate same in the volume space. And the measurement of angle of arrival by comparison of the phase relationship between signals coming from the separate antennas of a radio informator is called a informator radar or simultaneous phase comparison radar or phase comparison monopulse. In phase comparison monopulse radar, the phase difference between the echo signals coming from separate antennas is used for getting a angle error. That's why it is called a phase comparison monopulse radar. And this is the basic diagram of a phase comparison monopulse radar. Here two antennas are used. This is one antenna and this is another antenna, and these two antennas are separated by the distance d, and the range of the target is r, and the line of sight to the target makes an angle theta to the perpendicular bisector of the line joining two antennas. Therefore, the distance from antenna 1, this is the antenna 1, to the target is r1, that is equal to r plus d by 2 sine theta. And next, the distance from antenna 2 to the target is r2, that is r minus d by 2 sine theta. The phase difference between two echo signals in the two antennas is delta phi equal to 2 pi by lambda into d sine theta. Already we know if the angle is small, the sine theta becomes theta. That means the phase difference is a linear function of an angular error. That means it is used to position the antenna via servo control loop. This is about phase comparison monopulse radar. In this phase comparison monopulse radar, the phase difference between the two echo signals from two separate antennas used to measure the angular error. The phase difference is a linear function of the angular error. It is used to position the antenna by using a servo motors. And this is about phase comparison monopulse radar. And next concept is tracking in range. For most of the tracking radars, they continuously tracks the both range and angle. The range can be tracked by using a operator who continuously monitor the A scope or J scope presentation and position the hand wheel in order to maintain the marker over the desired target pip. As the speed of the target increases, it is difficult for the operator to perform at necessary levels of efficiency. To avoid this, we require a automatic tracking is required. The automatic tracking in range is obtained by using a split range gate. This split range gate consisting of two gates. One is early gate and other one is late gate. These are the waveforms of the first waveform is a echo pulse waveform, and second one is the early gate and late gate, and third waveform is the responses of early gate and late gate. By observing the third figure, the signal energy present in the early gate is less compared to the late gate. By subtracting the early gate response from late gate response, you can get the error signal. The error signal is used to position the early gate, reposition the early gate and late gate with the center of the echo pulse. The position of the signal energy contained in the early gate is less than the late gate. If the outputs of the two gates are subtracted, we can get the error signal. This it is used to reposition the center of the gate. The magnitude of error signal gives the difference between the center of the pulse and center of the gates, and the sign of the sign of the error signal gives the in which direction the gate has to be repositioned by using a servo controlled feedback control system. The first figure is the echo pulse, and second waveform is early gate and late gate, and third waveform is the responses of the early gate and late gate. At a particular instant of time, the response of the early gate is the signal energy present in the early gate is small, and the signal energy present in the late gate is high. And by subtracting the early gate response and late gate response, you can get the error signal. It is used to reposition the early gate and late gate at the center of the echo pulse by using some servo control loop. Some control mechanism is there. This is about tracking in range. The range can be automatically tracked by using a split range gates, and this is about today's class.